Alright. How can acceleration kill you? Speed never will. Keep that in mind. No matter how fast you're going, it won't have any effect on your body. It's the acceleration that creates the G-force that we'll talk about later. So, 4 calculations we're going to go through, examples. Mars, just existing on Mars, the acceleration towards the core. Free fall on Earth. Roller coasters, and crash deceleration.
So will any of these examples kill you? Alright, so in the first situation, we will examine whether or not the acceleration of gravity on Mars will kill you. And since gravity is a constant force on you, just the gravity alone is equal to the acceleration. And here's the equation for the acceleration on any planet. We have a few variables. The equation, you can see A is equal to gm over r squared, where g is the gravitational constant. It's a universal constant that's the same for all planets. We have m, which is the planet's mass, which on Mars is equal to, what is that? That's a lot. 6,400, no.
It's way more than that.
6.4191 times 10 to the 23rd kilograms. And then finally we have the radius from the planet's center, which on Mars is 3,397,000 meters, and we're going to square that in the equation. We're going and that's going to be undivided, or the divisor of the gravitational constant and the planet's mass as shown in the equation. So we put this all together and we calculated the gravity, or the acceleration, on Mars, and that's equal to 3.71 meters per second squared. Since we know the gravity on Earth is 9.81 meters per second squared, obviously, no, we're not going to die just from being on the gravity, just from the gravity on Mars. So the acceleration on Mars won't kill you. That's the first example of massive acceleration we have. The second one we thought of was free falling. We wondered if you were free falling from any point in Earth's gravitational radius, pole, whatever, will you die from the acceleration on that you get from falling from the sky? So, as you all know, and may have not realized, the gravity is constant wherever you are, well, relatively, on Earth, as long as you're within the general radius. And that gravity is 9.81 meters per second squared. So since acceleration is the only thing that affects you, free fall from any distance, and you won't die due to acceleration purely. Of course, the impact may be different, but we're just measuring acceleration here, so that's all we care about.
Alright, so our third example, roller coasters. So we determined through some research that going 16 Gs, which is 16 times the force of gravity, for 1 minute is enough to do make you have some serious problems. So we calculated that out. It's 157.14 meters per second squared. For 1 minute, that would get you to a speed of 21,081 miles per hour. Remember, speed doesn't affect you. That's just to give you some reference to just how much this would really be. Give you background, kind of a reassurance. Fastest accelerating roller coaster on Earth is 1.7 Gs, or 17 meters per second squared, approximately. So that's obviously nowhere near these numbers, and it's probably a much shorter time than a minute too, actually. So at any rate, example 4 is crash deceleration. So if your roller coaster derailed, you might have some issues with this type of thing. Our example is going to be a race car. Equation you all know and love. V final equals V initial plus acceleration times time. So, plugging in, we have our final velocity is going to be 0 because of us decelerating to 0. We're trying to find our initial velocity, and we discovered through some research that human body will not be able to withstand 47 Gs for for like this amount of time. So it obviously depends on the human and on the like axis rather of acceleration, but 47 G's is a pretty safe number, and that calculates out, and we have that's going to be 4.61 meters per second initial velocity. So that's approximately 103 miles per hour. So decelerating completely in hundredth of a second from 103 miles per hour will kill you, barring impact. So that's without factoring in the impact, just the deceleration is enough to kill you or give you serious problems for the rest of your life.
There you go.
So, to provide you with a miniature model, we're going to use this contraption of my childhood and this car. Which is clearly going to be going 103 miles per hour, proportionately to its size. We have our accelerator, our car, and impact. Alright. Obviously, an incredibly rapid deceleration, leading to